Let us see one of the most critical phenomena that happens during earthquakes, liquefaction, where the ground becomes liquid. And this is how it affects. You can see because the ground shaking, the decks have fallen into the river. A building which is intact, but the ground became a liquid. So the building got tilted. This happened in Japan in 1964. And this is the kind of crater that formed because of liquefaction. The whole ground becomes like a liquid, and you get all these collapses that are taking place. And you can see this is another major earthquake where so much of water came, slope failures. The ground shakes so much, you get craters, ground separating. And the soil here became a liquid, a solid at the dam or embankment, which was standing very safely after earthquake, because on a float, on a liquefied zone, it cannot be stable, so it kind of cracked, and this was the highway in Alaska. And you can see a dam failed. This is San Fernando Dam, which could not take the forces due to earthquake. This is another earthquake in Guatemala, where the whole ground started spreading because the ground below became a liquid. And this would be another in Argentina. And you can see this man standing, which means the crack is at least 3 feet deep. And this is what happens to ordinary buildings which are not being designed, and so they could not withstand, you get severe cracking. And this is the kind of crater that forms because the soil below became a liquid, and it comes like a volcano. All this sand you see is from below the ground. And this is how lateral spreading takes place in the California earthquake of 1989. This is the road in another part of California, San Francisco Oakland Bay Bridge. This is a little later, and highway, you can see how it cracked, and all the soil came from below the water, etc. This is the Loma Prieta earthquake in 1989, and this kind of damage in front of the bridge. Some more pictures, and here is the liquefied zone. Craters formed because whole thing collapses. This is the sand boil. It's something like coming, when you see the picture, it comes like it's boiling and coming out from there. This is our Bhuj earthquake, and the kind of damage very close to the epicenter. Even here, this is what happened in Ahmedabad. A lot of buildings collapsed. This is what happened to traditional masonry wall. You find the collapse here too. There was no reinforcement, so even the beams and columns failed. This was okay because the transverse reinforcement was good. This whole basement sank into the ground. It's amazing. There was a multi-storied building with what they call stilt, so that you can park your cars here. And because the ground failed, the whole thing, and the columns also, and the building came down. And this is what happened for structural floor. This is the roof collapse, and this is the longitudinal displacement, and the bridge completely moved away, and you find. So earthquake is one of the serious problems, and you have a water main here, and that failed, and there are a lot of flooding. This is a very interesting case in Kutch, wherein you find that the earthquake was in this direction, so the arch this way was stable but not perpendicular to that. This is another bridge. Because it was designed very well, it stood. What happens is you have this loose sand which is fully saturated. When you shake it, the particles try to separate out and the contact area is lost. Then they try to repack inside. But the whole thing happens in about 20 seconds. So at that time, for those 20 seconds, the whole thing behaves like a liquid because the particle contacts are lost. You can see here there are no particle contacts, and that is why it happens. So we look at two possible situations. This is residual shear strength, very low. Initially it's fairly high, it becomes pretty low, and then you get complete liquefaction. Whereas here the stress is reached after large strain, so we call it cyclic mobility. So when you are doing shear test, you have to apply a number of cycles of loading and unloading, find out when these two phenomena occur. That's how we use cyclic triaxial test to determine the liquefaction potential.